So if we have the limit of x approaches infinity of a function, that means that what will the output of the function be as x gets as big as it can possibly get? So like right here, we have the limit as x approaches infinity of 1 over x. And so we just think, what will 1 over x approach as x gets infinitely large? And we can think about it like if we input a small number like 1 over 3, that's just 0.3 repeating. If we insert a bigger number, 1 over 100, that's equal to 0.01. And we can just keep inserting bigger and bigger numbers, and eventually 1 over x will approach 0 as x gets infinitely large. So we can say that the limit as x approaches infinity of 1 over x equals 0. And 1 over x will never actually equal 0 exactly, just like how x can never actually be infinity. Both of these values are just approximations of what they approach. X can never reach infinity, but it can approach it, and 1 over x cannot equal 0, but it can approach it. And we can also have a limit as x approaches negative infinity, and it's pretty similar. What this means is that the limit as x becomes infinitely large in the negative direction. And for this one, 1 over x is still equals 0. It's the same answer because if we have 1 over negative 1000, that's just negative 0.001. And if you insert infinitely large numbers in the negative direction for the denominator, it's going to approach 0. So the limit as x approaches negative infinity of 1 over x equals 0. And it might not always be the same for infinity and negative infinity, but in this case, it just happens to be the same answer. Now, let's do an example. Here we have the limit as x approaches infinity of 2x plus 3 over x minus 4. And this is kind of different from regular limits. Like if x approached 5 or something, then you could probably just plug 5 in and you get your answer. But we can't just plug infinity into this expression because, well, it wouldn't work. So what we try to do is solve it algebraically or just thinking about it logically. For this one, what we can do is divide both sides, the numerator and denominator, by x. So we get 2 plus 3 over x over 1 minus 4 over x. And what I can notice is that if we plug in infinity now, well, technically it won't work, but if we think about it, 3 over x as x approaches infinity, this is just 0. And same for 4 over x, 0. As x gets infinitely big, 3 over x and 4 over x will both approach 0. So technically, this is just 2 over 1, and the limit is just 2. And there you have it. This is the way to solve these types of problems, like algebraically or just thinking about it, because you're not going to be able to plug in infinity into any of the expressions you're given. Now, let's do another example. This one is the limit as x approaches negative infinity of this absolute value of x over x. And if we're approaching negative infinity for x, then we're only considering negative values basically. So we can rewrite this absolute value of x as negative x, because if x is negative, then the absolute value of x will just be the negative of that. So negative x over x, which is negative x over x, and then x over x, no matter what the x's are, this is always going to equal to 1. So this is just going to be equal to negative 1. So the limit as x approaches negative infinity of absolute value of x over x is equals to negative 1. Now let's get into some practice problems. This one says to evaluate the limit as x approaches infinity of 1 minus 2x over 3x plus 2. If you think you know how to do this problem, then pause the video and try it. But this problem is pretty similar to the one that I did in the examples. So what we can do is divide both sides by x. So we get 1 over x minus 2 all over 3 plus 2x. And as x gets infinitely large, that's what x approaches infinity means, 1 over x approaches 0, and so does 2 over x. So in reality, this is just negative 2 over 3, which is what the limit approaches. So the limit as x approaches infinity of 1 minus 2x over 3x plus 2 is negative 2 over 3. Now let's do another example. If you think you know how to do this one, pause the video and try it. This problem asks to evaluate the limit as x approaches negative infinity of 4x cubed minus 2x plus 1 all over x squared minus 2x plus 1. And for this one, well, let's just try dividing both sides by x again, and we're going to get 4x squared minus 2 plus 1 over x all over x minus 2 plus 1 over x. And as we discussed many times before, 1 over x is going to approach 0, so we can get rid of those. And now we're just left with 4x squared minus 2 all over x minus 2. And again, now let's try dividing both sides by x again, and we get 4x minus 2 over x all over 1 minus 2 over x. And 2 over x also approaches 0, so we can get rid of those, and we're left with 4x over 1. And just think about it logically, well, first of all, we can write it as 4x, and thinking about it logically, as x gets infinitely large in the negative direction, 4x will as well. So the limit approaches negative infinity. And there's kind of a disagreement on how we should write this. Some people write if the limit approaches infinity or negative infinity like it does here, then we should write DNE, or does not exist, because the value of a limit is supposed to be a number that exists, and negative infinity and infinity technically don't exist as numbers. So just for your information, on the IB exams, you're supposed to write does not exist, but on the AP exams, you should write infinity or negative infinity. Now, let's do another practice problem. If you think you know this one, then pause the video and try it. This one asks to evaluate the limit as x approaches infinity of the square root of x squared plus 2 all over x minus 5. And for this one, well, we can't divide both sides by x because there's a square root on top. And we can't really think about it logically because, well, it's just kind of hard. So what I can notice is that if we take out a square root from both sides, we can just get square root of the whole fraction. So square root of x squared plus 2 over x minus 5 squared, because the square root of x minus 5 squared is just x minus 5. So these two expressions are equal, and that's what we can do. So the limit as x approaches infinity of this, since there's a square root on the whole thing, we can ignore this for now and just add it on later. And so x squared plus 2 all over x plus 5 squared, we can just factor this x plus 5 squared out into x squared plus 2 all over x squared minus 10x plus 25. And now we can do our method of dividing both sides by x. So we get x plus 2 over x all over x minus 10 plus 25 over x. These become 0, and we're left with x over x minus 10. And now let's try dividing both sides by x again, and we get 1 over 1 minus 10 over x, which is just 0. So 1 over 1 is just 1. And now remember, we have to add the square root on, but it doesn't really do anything because square root of 1 is just 1 anyways. So the answer is 1. So the limit as x approaches infinity of square root of x squared plus 2 over x minus 5 is equal to 1. So everything that I explained and all the problems that I went through in this video should teach you everything that I need to know about limits at infinity. If you learned something from this video, or if you enjoyed it, then please consider liking or subscribing.